Well, good afternoon, good morning, good evening to everybody. Welcome back to the P2 Live Forum. And today, August 5th, we have just an assortment of things to discuss and really no agenda at the same time. So to kick it off today, while people get seated, Kevin's going to show us his progress on his robot recently. So I think he's got something set up in the backyard. And while he's doing that, if anybody has a topic they want to share or discuss today, drop me a direct message so that I can write it down and be sure that any support question or anything that's of interest to you is discussed with all the right people here. And if there's any update on any community projects like the P2 Cube or porting simple tools to the P2 or any of Johnny Mac's code efforts, please let me know so we could talk about those too. So Kevin, if you're here and you're ready, you want to show us how you're doing with the robot?
Yeah, this is the platform for the motor mount wheel kit.
Okay, so we're live in Kevin's backyard.
It's hard to see on the screen. I hope you can see it.
Yeah, that works.
Got the motor mount wheel kit.
Looks like he's going to do the remote control and camera management on his own. I'll spot his video so we could all see it. Kevin, if you have a parent handy, have them hold. Okay, that's better. I was going to suggest they do the camera. Ah, this works great. Okay, super. So he's doing more than I am at this stage. Bring that robot back into view.
It's too hard to control because I'm using the throttle and that for the control, and the throttle doesn't bounce back to the middle because it's made for the drone, but it works for testing.
Okay, extend it across the yard outside.
So I know a little bit about this project. We provided Kevin with this motor mount and wheel kit, and he's got a couple HB25s on there from Roy Eltham. And I think he went to Harbor Freight for a caster wheel, and somewhere he picked up a big 12-volt battery. And yesterday he was just going back and forth. Today it's turning. So Kevin, we'll hear you much best when you're close to the audio, when you're ready to tell us about it.
Okay.
And he's using, definitely using Johnny Mac's object for the Fly Sky transmitter receiver.
Okay, here.
So all I need to do to the code is just add a few lines for the motor control. I don't know if you want me to show it.
You had a P2 edge on there as well?
Yeah.
Yeah, the robot's now too heavy to pick up and throw in front of the camera. Okay, I see.
Powered by this power bank for now.
Wow. So questions, comments for Kevin? Well, how did the assembly go on this, Kevin? Did you cut that out?
Yeah, my dad made the base for it. The holes aren't very good.
Repeat that, but closer to the audio source again.
But more in the holes aren't very good, so it's hard to mount it.
Little trouble on the audio. Does anybody want to get a quick look at his code? He's got a computer here apparently.
Yeah, sure. Kevin, how many processes? Are you just using the P2 Edge and that's it?
Yeah, that's it. And the H325 motor controllers.
So Kevin, this is Johnny Mac. Can I make a suggestion?
Yes.
One of the things that I do for my friend John Huffman at JonnyJib for our camera controls is we put in what's called a dead band. In the beginning, when you started it up, I think that was because you said that the potentiometer didn't return to 0. So what we do, because we have that same problem with our camera controls, is that we subtract out that middle range so that 0 is actually a whole group of numbers, and then you can go either up one way or down the other way. If you want, you can call me and I can show you how I do it in code, but that'll give you the ability to have imperfect joysticks and not have a runaway robot.
Yeah, I sort of already had that, but it's not very good. It's just a tiny bit of range in the middle.
Yeah, so, well, that's what I mean.
Not much.
You put a dead band in there so that that little wobbly imperfection doesn't cause your robot to move when you don't want. Again, we have to do that on camera platforms.
Yeah, thank you.
Mhm.
Yeah, I also haven't gotten the
I believe Kevin was talking about the encoders there. Because he's
Yeah,
using external optical encoders.
Yeah, I don't have those working right now, but I tested them and they work.
Oh, that's good.
Can that motor he's using, it has an encoder on it, right?
Yeah, it's got 36 count optical, one of the QRD sensors, photo interrupter. So what he doesn't have is any firmware for it.
Right.
There is some P1 firmware for it that goes with the old Eddie Arlo platform that we could dig up for you, Kevin. Might help you.
Yeah, thank you.
Yeah, you're welcome. Well, good progress there.
Yeah, it's looking good.
Yeah, it's super. It's a long-term project because Kevin, you were waiting for motors from us for quite some time. And then finally this big box of metal showed up.
Yeah,
Yeah, now you gotta figure out where to do the permanent spot.
Any other questions, comments for Kevin? All right. Good job, Kevin.
Thank
Thanks
you.
for sharing.
Yeah, thanks, Kevin.
okay, you're welcome.
Since Johnny Mac mentioned it, John Huffman, who came to our office a while ago with Johnny Mac, has a new product in design using the P2 Edge. And this is his PCB layout that we're looking at. And the edge sits right up here. So he allowed us to share his schematic for his PCB layout. Good job, Johnny, if you're out there. Also, these are finally headed into production on Monday. So after a
Okay,
long,
John was gonna say something.
okay.
Well, I was just going to comment. John has been putting in a lot of hours on that design. What's on there is you can obviously see the edge, and then those circuits down in the lower left corner of that area. Those are motor driver outputs for standard DC motors, but he's got some connectors on there for modular controls as well. So John went through and reviewed every product that he's created, and he's making it modular so that anything he's done in the past, he can do with this. So I've ported most of the objects from the P1 to the P2 that we've used already. But, you know, for example, this device for a specific application will use these Dynamixel motor controllers. It looks like a servo, but they're smart. These run on a network and they're very precise. So we're going to use this to control the focus and zoom on a lens. So I've got to port that code and do some display code. But yeah, John, I get occasional texts from him at weird hours because his wife is out visiting family right now. So he's on his own and he's just working day and night on this thing.
Thanks for helping him along too, John. The new P2-EC, P2 Edge on Monday, we got this on the pick and place. So parts are finally coming, which was a big challenge. Lots of delays. Things were in stock, out of stock, prices changing on us. But anyway, we're finally there. So Chip, do you want to comment on the new features here? I think I have them right.
Yeah, we've been over this a few times on this meeting, but yeah, we have a very accurate clock source now. And Ken, is it 0.5 ppm? I can't remember. I'm also remembering 150 parts per billion, or is that something else?
I think it's 0.5. Michael provided
Okay.
that.
Yeah, so we were having the last part we couldn't get was a little 6-pin dual inverter that we have 2 per board. One squares up the clip sine oscillator to 3.3 volts and the other runs the LEDs. So those should be in soon, and then we'll build a bunch of these. Ken, how many are we making?
500. And Chip, there's a micro SD card socket on there too. This is a big
Oh, yeah.
improvement right here in the circuit board
Right.
on the front side.
Right. So this will hopefully solve the power input problem to the what's it called, the Johnny Mac board by tolerating all kinds of much wider range, and you don't have to worry about reversing it. It won't hurt anything.
And it also, doesn't it really lock in the importance now of having a real 5-volt power supply, so you don't blow up anything on the Johnny Mac.
If you're using the 5-volt power supply pins, yeah.
So if you don't have a benchtop supply, then use our 120 volt to USB to 2.1 millimeter jack combination.
Yep. And Ken, Michael was going to start, in order to make this into the 32 megabyte P2 Edge with the SP or PS RAM, where the Parallax logo is, there's going to be 4 little 2x3 millimeter chips up there. And otherwise it'll look pretty much the same. You know if he started that yet?
I think he's next week. We're in a race to get this done and prototyped and just proven so that he could leverage it.
Yeah, okay.
So if he pauses a little bit, it's no problem.
Okay, good. Yeah, that's what there's the front.
Yeah, SD socket, that looks nice.
Ken, do you also have we shown the final layout for the motor control board?
I have that too, yep. So I don't have the schematic handy, I can get it, but here's the simulation of the board.
You know what, I'm not seeing, let's see. Oh, there we go, okay. Yeah, so those are 30 amp connectors. Turns out a lot of people are selling motor control boards, but they only have like several amp wire terminals, but these are real, I think they're rated for 32 amps, or 25. Anyway, could be a potential weak link, but we don't know, what the heat dissipation on this is going to be like.
I've got 2 streams.
So this will give us 4 phases of control. So So
And the
September
plan-
1st, huh, Ken?
September 1st, yeah, circuit boards ordered, and that was about as quick as we can get them for the price we want them.
Yeah, okay. That board's actually gonna be pretty small.
One thing I realized too, Chip, after we got into this is the motor leads on these hoverboard motors are not that long. So like even the
Oh,
robot
right.
Kevin showed, when he starts using these, he's gonna have to be extending wires.
Yes,
So we could sort that out at some point later, once we know everything's working.
right. Yep,
And we also came up with a unique caster wheel design. This is actually an air-on chair caster, low cost, get them off Amazon. They're a standard size. They fit all kinds of chairs. And this time, instead of machining many parts like we've done in the past, we just have one part that has 1/4x20 screw mounts on it. And then we'll have a set screw that goes into this, looks like almost a retaining ring, but it's really a little rubber ring that lets the caster wheel sit into the chair socket. So a customer will just have to mount this part to their robot base.
Ken, is there like a little recess inside the hole?
There is, yeah. It's a
How is that?
prototype.
That must have been cut in some kind of circular pattern, right?
You mean the way it was milled?
Yeah,
Yeah, this was done on a mill with the big cutter just going around, not on a lathe. It was too big to chuck in a lathe, at least with our
But there's-
tools.
but there's an interior feature on that hole to capture that little ring, right?
There is not. There's a recess. That ring is actually a recess in the shaft. So what we're doing is putting a screw in there just to keep the caster from sliding up and down. So it won't turn because the friction is greater than, it's like a press fit. It's a tight fit, but the
Right.
friction is lower with the caster,
Yeah,
the bearing that's on top of the caster, so it'll turn. We just have to hold it in there from plopping out.
right.
Any
Good.
questions on these things? Comments? Who's looking forward to building a big robot? Nobody wants to admit it?
I've never done that.
Yeah. So at
Ken,
this
do you have
point,
some, do you have some pictures of all the machine shop stuff too?
I do.
We've moved a lot of equipment lately.
Bring those up. Hopefully I do. So part of this effort, I think I have most of what we need.
You had
Not-
something up before the meeting started.
So I don't have pictures of the CNC shop as finished by you, but I do have pictures of some of our chaos going on. I think I'm sharing now.
Yep.
Yeah, so for those who've been to Parallax, you know, the inside of our offices was this burrito shop look. So we've fully demoed that. And we're cleaning up things in preparation partially for an event at Parallax, hopefully in March next year. So our main office now is one big empty space getting recarpeted and painted so that we can have space to mill around and have tables where people can share what they're working on, and then have a classroom on one side and fit very comfortably 100 to 200 people. So that's what that's about. And then of course we also did a new roof, or these guys did a new roof. The CNC stuff we pulled out of the office and moved it up to Red Bluff with Chip, where it's joined a couple of other machines. And this has been really good because we have access now to a very skilled worker, Doug Pintak. He used to work at Parallax, who has all properly licensed software tools to run these machines. So we're underway there, and we're building about 2,000 parts right now. And the poor guy has to start out next week with our gripper for the small robots, which went out of stock. And he's making new tools for that. Chip, if you have a picture of the CNC
I have
shop.
a picture. Let's see.
Okay.
Oh, wait, let's see. This is this panoramic picture I took with my cell phone. So this is almost looking like 180 degrees. But you can see there's our old manual mill. We bought that thing back in 1998 and learned the machine on that. And then Doug has this mill and this lathe down here. And then these two middle machines came from Parallax. So he's got quite a few orders to build Parallax stuff.
Are these 4 or 5 axis?
I think they're, Ken, what would you say they are? They're like just 3, aren't they?
Well, the mill, the lathe has live tooling on it
One.
and the 4th axis,
4.
but I think the rest are 3.
Yeah, and Doug has made some really nice live tooling for like the lathe, so he can control the spindle position. So he has this live tooling on the side that can come in and drill and put like a chamfer on holes. So he actually makes stuff. He kind of adds to the machines in order to build stuff efficiently. But I've been involved in this quite a bit, just setting it up and helping him. It took us a while to figure out how to position everything so that it was ergonomic. So if you look at these machines, they have these doors that open on the backs, these big service doors for all the internals, all the electronics, and they have to have 3 feet of clearance. And then the chips have to come out of the right front of the machine. And so it turns out the only way to like efficiently position these things is to stagger them, kind of like parallel parking in a parking lot where everything's angled a little bit, so that those chip removal bays are all, accessible, and there's room around things. So we went through lots of moving stuff around before we figured out that this was the best way to do it.
And it can be a messy operation too. Disposing of the chips and then disposing of the coolant.
Yeah. Yeah. We're thinking that we should try to make some kind of distiller that fits over like a huge garbage can, because it's getting difficult for machinists to dispose of the cutting fluid, which is really just vegetable oil, which is now in water, which has come into contact with aluminum, which, the state considers toxic. So we're thinking if we could, this stuff only mixes, it's like what, 8 to 1, Ken?
Yep.
So we should be able to get rid of the water and get back down to some denser oil that we could, more easily dispose of at the material recovery facility.
Funny story though, Chip, speaking of material recovery facility, we had to dispose of some coolant, and I suckered you into taking a couple 5 gallons there, and I was smart enough to get in front of you in my car on the way out. And I successfully disposed of mine, but by the time you showed up, we were wearing out our welcome.
Yeah, there was we ran into an activist at the drop-off point, and he really lit up and accused us of cheating the system, and this was commercial, which it kind of is, but there's no other way to get rid of this stuff. And it's a one-time thing for them because we just have to move the machines and we can't move them with all the coolant in them. So anyway, he really lit up, and I didn't know what to do. So I just had to drive away. He was claiming this stuff was, what was the word he used? Corrosive, which actually the whole point is it's not corrosive, right? But anyway, he just saw this guy that looked like me come through there with 3 identical barrels that I was going to give him. And he wasn't going to take it. Even though we got flagged through the, control booth okay, So I could have probably just folded my arms and sat there until the boss came out and made him take the stuff, but I didn't know what I didn't want to have any trouble, so I just left. So now the stuff's up here in Red Bluff, so we might take it to our local place later or distill it down and get rid of it. The less material you have, the easier it is to get rid of. But we had, how many gallons of this stuff, or how many 5-gallon buckets of this stuff did we have?
Enough to wear out our welcome.
Yeah, he said, hey, you guys have been coming here all week with this. And there was still like another 2 or 3 trip loads worth of stuff to take. But anyway, now we've got the machines up here. They're all set up and everything's okay at this
So
point.
even this activity diverted some of Chip's attention. So that was my responsibility. I take that for you, Chip. Otherwise, you should be showing floating point libraries by now.
Absolutely, yeah. Yeah, so
Please,
now
Chip.
Doug's got enough, he's got enough orders to keep him busy until December or so.
Chip,
Yeah,
did I understood it right? You have all that stuff in Red Bluff.
yeah, this is inside of a room in the barn. This was where we had the tortilla factory before.
Yes, I talked about that. So you are depending on that huge pole transformer on the other side of the road more than ever.
We're talking about the, did you say transformer?
Yes, the one that was hit by a boat last time. You lose your power input, your AC power.
The car accident that took out the power pole.
Oh, yeah, no, that was down the road. Yeah, that didn't hurt us directly. I mean, it caused a power outage here temporarily, but it wasn't our pole. But in this room, see, it was really convenient because we have all these power drops that are like, 208 3-phase. Actually, they seem to be more like 240 3-phase. And we have air drops. There's a big compressor on the other side of the wall. So it was just perfect for a machine shop anyway. So it's very convenient. We have all the power that we need to hook up all these machines right where they're sitting.
Okay, thanks. I wasn't sure I had understood it right, that you get all that stuff into Red Bluff.
Oh, you understood
Yeah,
it
it's all up
correctly.
here now.
Okay. Thank you.
Oh, Ken, you're muted.
Thanks, Chip. Is anybody working on any new P2 projects or in need of any kind of support questions?
Yeah, Ken, I got a question for you. Those BLDCs, you have 100 in stock. I can't seem to find them on your website. Is there an SKU number?
They're not listed yet. They will be like Monday or Tuesday.
Okay. And what kind of power supply are we looking at with the controller that's coming on in September and the motor that you have there? Is it like a 40 volt? What's the maximum?
I think it's up to 40 volt, and the request I gave, my input was to use a 4 to 5S LiPo pack in the design. So what are we looking at there? 18 to 24 volts.
Okay.
Is likely for a robot. Those are common, lower cost LiPo batteries, but beyond that, things get very big and very expensive and very dangerous.
Right. And how many amps are in the ballpark?
I think this is probably, Chip, you guys figured it out, but wasn't it like 10 to 20 amps maximum?
For the motor controller?
Yeah.
Yeah.
I think it
18
was like
volts.
25 amps and 40 volts.
Okay. Okay. Wow. That's good.
But it might have been, he might have like derated it just to be cautious a little bit, maybe to like something slightly less than that.
I
Okay.
think this is a very powerful system.
Yeah, it
And
sounds like it.
what I've been working with up till now has been 12 volts and like 5 amps or 10 when the motors are locked.
Sure.
So probably half, but these motors carry around people. What are you going to do with it, Kevin?
Well, I just not, well, I'm just going to be running it in the lab. Well, maybe at a makerspace, maybe electrical theory, that sort of thing.
Okay.
Yeah, I'm not going to be riding on it.
Well, since we've cleared out the Parallax office now, the internal main space, I hope to have a few in there running wild pretty quick.
Yeah. Yeah. Once I see it actually rotating at speed, I'll probably put a board on top of it and try to ride on it.
They're going to be a lot of fun.
If it drives resistive loads, it shouldn't even get hot. It's just the back EMF that's going to create heat on that board.
Uh-huh. Yeah, I want to experiment with it. So I'll get all the hardware from you guys when it shows up and set it up in our lab.
Yeah, it could be used for a lot more than just controlling motors, I think.
Uh-huh. Yeah, I'm looking forward to it.
And I think we're all going to need to be getting LiPo batteries. I don't know how many of us have 20 volt, 20 amp power supplies on our bench. Maybe you do.
Well, yeah, I got the, just your normal bench supplies, 30 volt, 5 amps, 3 in 1 units type thing, but yeah, you're pushing beyond the capabilities of my office. I'd probably have to take it out to the garage. All right, thanks.
Yeah, you bet. Any kind of support questions since we have Chip here? Coding questions? P2 implementation?
I'm sorry the floating point's not done yet. I've just been kind of thinking about all kinds of stuff and haven't been super focused on this, but I've got the code that runs in the interpreter almost done, and then I just need to go do the part for the compiler.
So it's implemented in the interpreter chip. It's not a separate object file.
Right. So far, it's taking about, let's see here. It has added maybe half a K to the interpreter. So it's much faster that way and more automatic. So it's probably worth half a K.
Well, it'll be interesting that board that Ken showed that John Huffman is working on, that's a camera controller, and we'd have lots of math stuff that we have to do in fixed point. Since that's the P2 board, it'll be interesting to see if this will be beneficial.